In this lesson, we are going to explore the most common building block of a saga, which is a generator function. Now, the generator function is a new-ish feature that was brought into the JavaScript ecosystem and native to JavaScript now. And what it is a function that resembles async await. Now, it's not exactly async await. It's got almost a different flair to it, but it's very similar in the sense that with our async await functions, we await our asynchronous events, right? Our promise-based events, where we pause the execution inside of an async function whenever we see the await call. Well, generator functions are very similar in the sense that they also pause their execution whenever they see a specific key inside of the function, and that key is called a yield. Now, I'll show you what that looks like when we write our first generator function. Now, in order for us to do it, there's actually a special syntax. We actually have to declare it with our old school style of writing function declarations. So we actually got to write function, but what we do is we put the star to declare that this is a generator function. And then what we can do is we can name our function. So I'm going to name it gen, and it's going to take no parameters for now. And all this function does is it calls console.log a, just the letter A, and then it console.logs the letter B. Now, when we instantiate this function, meaning that when we invoke it, we actually get back this generator object, which we can cast to some variable g, right? I'm just going to name this constant g, and it's going to be equal to us invoking gen, the function. Now, if this was a regular function, the moment I invoke gen, console log A and console log B will be logged out to our browser. And then g would just be set to undefined because functions that don't return anything would just return undefined. But in our case, when we invoke this gen, we see that nothing has happened. In fact, if we were to log our g, we see we get this weird gen suspended generator kind of object, right? So this is a generator object. And what we do on it is we call .next on it. And what .next will do is it will actually resume the execution inside of our function. So at this point, when we invoked it for the first time, we instantiated this generator object that actually is aware of the code inside of this function, but the execution inside of the function is paused. So until we call gen.next, this function actually will not run our console logs. But the moment I do, we see that it does. It logs out A and B, but then you see that we get back this object from calling .next. And what it is an object with a value prop and a done prop. The done prop is a Boolean telling us if there's anything else in the function to run or has it run through its entire course, which we know it does because all we did in our function was console log two things. Now this will change once we start using the yield key, and the yield key will also give this value a value. And I'm going to show you how that works. Let's refresh and let's make a new function, right? So again, we're going to call it gen, but this time we're going to take some integer value. And what we're going to do is we are going to yield the value that we pass in. The next call, we're going to yield I plus 10. So that's all we've done is essentially we're saying we write this function, right, called gen. It takes some integer value, some number, and then it yields that number that we passed in. And it also yields then the number plus 10. So now we're going to set some g value equal to our gen initialized with the value of, let's say, actually 5. Now what happens when we call g dot? We know that we are going to actually get back that similar object that we saw before, right? You remember when we logged it, when we invoked next the first time? That object with the value key and then the done key. Well, I'm actually just going to make sure to hold on to that value. So I'm just going to call it gobj, right here. And now when I call it, you'll actually see that when we see what's on our gobj, right, our gobj is equal to that object, except now value is the I value that we yielded out the first time. And we'll also see that done is false, meaning that there's more that we can actually continue the execution on inside of our generator function. If I were to call g.next again this time, right, and let's set it to another object. Let's call it just jobj, right? Well, now we'll see that jobj has the value of the next yielded value, which is 5 plus 10, which gives us 15. It also now sees that done is still false. If we were to call g.next one last time, then we see that the done is true, but there's no value that gets returned in the undefined. Now, this is the main thing to remember with yields. The moment we call yields inside of our generator function, the yield key is pretty much telling our generator function, oh, hey, I don't want to do anything with this, right? I'm just going to resolve it however it is. If it's an asynchronous request, I'm going to resolve it, the async request. But I'm going to pass that value out into this object that we get back, right? And I'm going to set it to the value prop. Now, you might be wondering, when it's done, is there a way for us to get a value in this function? Well, actually, there is. The way that we would do it, right, let's just copy this, is we would actually cast it as the return value. So the last thing we can do is say return 25. And now if we did the same thing as we did last time with gen5, if I do g.next, right, we see that this is up to our second yield. If I do g.next one more time, well, the final value that gets resolved is our return from our function, and then the done is true. But the main benefit is that the yield will invoke the value, right, of whatever it's yielding and return it outside of our generator. This is primarily what generators are used for. It's just if you want to stash multiple executions, but you want to control when you want to move and continue the execution in this function onwards. And this is the basis of sagas. Sagas work on this yield-based format because they need to know and give us control over when we want to continue with an execution of the block of code that we've written, or we want to do something with it first. Now, it'll make more sense once we start writing it, but I just wanted you to see this generator syntax. I did not want you to be confused by what we're about to write, because what we're about to write is going to look kind of different from code that we've written before. The closest comparison I'm going to draw, again, is to async await. But now that we've seen this as well, we just need to remember that whenever we see yield, we just need to know that our code is stopping at this point, even if it's asynchronous code, just like async await. So let's dive into implementing sagas into our code base.